Hello everybody, welcome back to Math 2413, more on math. Today we're going to look at Chapter 2, Section 4 of the homework. Alright, let's look at the first page. First question. Find the slope of the curve y equals x cubed at the point -1, -1 by finding the limit value of the slope of the secant line through P. And then find the equation of the tangent line. Okay, so this means to find the slope of the secant line, that means we're finding the limit as h approaches 0 of f of x plus h minus f of x over h. So what we have here, we have our f of x is x cubed. So we have that part. We need to find the f x plus h, which is x plus h cubed. So we have to work that out. X plus h times x plus h times x plus h. That's what that means. So multiply these two together first. We'll get this 2xh plus h squared. So multiply the first two together, apply FOILing, you get that. Repeat the process. X squared times x is x cubed. X squared times h is x squared h. 2xh times x, 2x squared h. 2xh times h is 2xh squared. Then h squared times x is xh squared. And then h cubed. So this is the entire first part. So we'll look at the limit as h goes to 0. X cubed plus x squared h plus 2x squared h plus 2xh squared plus xh squared plus h cubed minus our function x cubed all over h. So the x cubes cancel, leaving us with the limit as h goes to 0 of x squared h, 2x squared h plus 2xh squared, xh squared plus h cubed all over h. Factor out an h out of the top. We have x squared plus 2x squared x cubed. No, that's it. So it's x squared, 2x, the h is gone, plus 2xh plus xh plus h squared. The h's cancel. So we have the limit as h goes to 0 x squared times x squared times h. 2, okay. All right. H's go to 0. So we're left with x squared plus 2s is 3x squared. At the point -1, -1, so x equals -1, the slope is 3. The slope is 3. Now I've got to find the equation of the line tangent. Since I know the slope, I have a point. All I gotta do is find the equation of the line. So plug in what I know. This is x, this is y, and that's m. So we have to solve for b. So y is -1, m is 3, x is -1, plus b. So -1 equals -3. Add 3 to both sides. B is equal to 2. So m is equal to 3. B is equal to 2. Put it back in that equation. M is 3x plus 2. There's the equation of that line. It's 3x plus 2. Alright, that's the first one. Second page. Jeez. Number 2. Use the following function and its graph to answer a through d. It's a piecewise defined function. F of x is 5 minus x whenever x is less than 3, 3x over 4 plus 2 whenever x is greater than 3. What we notice then is x never equals 3. So it's not a continuous function. Alright, let's look at the first one. Find the limit f of x as x approaches 3 from the right and from the left. Select the correct choices below. So, if x is coming from 3 from the right, that means it's going to be greater than 3, so we use this equation. X approaches 3 from the right. We have 3 times 3 over 4 plus 2, which is 9 over 4 plus 2, 17 over 4, we get 4.25. That's for coming from the right, the bigger equation. Now from the left, x is less than 3. So we have 5 minus 3 is 2. This is from x coming to 3 from the left. So it's 2. Does the limit of f(x) at 3 exist? No, because there's no value there, and they're approaching different values going from left and right. So no, it doesn't exist. Find the limit f of x as x approaches 5 from the left and from the right. Since x is going to 5, that's bigger than 3, so we use this equation for both of them. So use 3 times 5 over 4 plus 2. 15 over 4 plus 8 over 4, 23 over 4 is 5.75. Since they're both using the same equation, it's going to be the same value. D. Does the limit x over 5? Yes, because they both equal 5.75. Alright, so that's that page. Next one. Number 3. Graph the function f of x. It's a piecewise defined function. When x is not equal to 2, or when x is negative 2 equals 4 minus x squared. And then when it equals negative 2, it's 4. So let's look for negative 2 has to equal 4. If that one's open, wrong. No, this one's open, it's wrong. So it's got to be either this one or this one. When x does not equal negative 2, so in other words, it has to be an open circle at negative 2. That's a closed circle, so the answer is D. Yeah, so now find the limit as x approaches negative 2 from left and from the right. From the graph, if we're going to negative 2 from the left, it's going to 0. If we're going from the right, it's going to 0. So the limit exists, and it's negative 2. The limit from the right, it's also going to 0. Does the limit at x negative 2 exist? Yeah, we just saw it. They both of these equal the same thing, so it's 0. Okay, find the following limit. X approaches negative 0.2 from the left. Since the only restriction we have is the numbers have to be greater than 1 or greater than 0 because it cannot equal negative 1 or anything smaller. So what we do here is just plug them in. Negative 0.2 plus 5, negative 0.2 plus 1. So it's 4.8 over 0.8, which is square root of 6. Because move the decimal out, 8 goes into 48 6 times. Number 5. Ooh, okay, now we're getting into the trigonometric ones. Use a relation, the limit as theta goes to 0 of sine theta over theta equals 1. So using the constant multiple, this 6 goes out in front. Sine radical 3 theta over radical 3 theta. So basically, as long as these are the same, that equals 1. So it equals 6 times 1, 6. Right, next one. So first off, that's a leading coefficient, so it's y goes to 0. We have sine of 7y over y. In other words, this and this have to be the same, so it needs a 7 here, so we have to put a 7. If we put a 7 there, then we have to multiply by 7, because these two will cancel out. So that equals 1. The answer is 7 over 16. Let's look at this one. Remember, tangent is sine 11x over cosine 11x divided by x over 1. Take the top fraction, leave it alone. Sine 11x, cosine 11x. Flip the bottom, so it's 1 over x. So we have sine 11x over x times 1 over cosine 11x. This one needs 11 in front of it. So if we put 11 in front of it, I gotta put 11 out in front of the entire equation. Since I'm dividing here, I have to multiply. So it's gonna be 11 limit as x goes to 0, sine 11x over 11x times 1 over cosine 11x. This one goes to 1. When x goes to 0, cosine of 0 is 1. So 11 times 1 is 11. So this one, as theta goes to 0, we have two parts. We have sine theta times 1 over sine 9 theta. Limit theta goes to 0 of sine theta times limit of 1 over sine 9 theta. This one needs a theta. It needs 1 theta. So we put a 1 in front because it's dividing that. This one has a 9, so it needs a 9 on top. So we divide it by 9. So now that equals 1. That equals 1. The answer is 1 over 9. Alright. Since this one has, well, this one needs a theta on the bottom, but as theta goes to 0, this one's going to become a 0. So anything times 0 is 0. Alright. Limit as x goes to 0. Sine 5x cosine 5x over sine 9x over 1. Limit as x goes to 0. We have sine 5x over cosine 5x. Flip this one, so it's 1 over sine 9x. Limit as x goes to 0, we have 3 parts. We have sine 5x times 1 over cosine 5x times 1 over sine 9x. So this one needs a 5x on the bottom, so we multiply by 5x. This one needs a 9x on top, so we divide by 9x. The x's cancel. This goes to 1. This goes to 1. Cosine of 0 is 1, so this is a 1. So it equals 5 over 9. If you know that the limit as x approaches c exists, can you find its value by calculating limit of x goes to positive? Give a reason why. First off, no. Well, let's see. If it does exist, can you go with this? Yeah, if it exists, then it has to exist to both sides. So it can't be these two, because if it exists, then it has to be both directions. Yes, because epsilon greater than 0, so as x approaches c, then fx has a left hand. No, I want a right hand. As x to the limit approaches, and if and only if it has a left hand and a right hand limit, and they're equal. And that's what that says. This is the left hand, this is the right hand. And if they're equal, that's the limit. Suppose that f is an odd function of x. Okay, it's an odd function. That's going to be important for us. Does knowing that the limit of f of x equals 3 as x approaches 0 from the left tell us anything about the limit of f of x as x approaches from the left? This is from the right, I mean, from the left. Since the given function is an odd function, that means the positive and negatives will give you the same for all x in the domain. And x is be negative if I change x, the value x. Yes. Here you have to understand, remember the definition of odd function. An odd function is that if I change the value of x, it changes the value of the answer. All right. Well, that does it. All right. Good luck, everybody.